Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, today's topic of the lecture is the matter and its classification. So, let us start. What is matter? I'm writing. Um, what's matter? The matter is anything that occupies space, possesses mass, and can be felt by anyone or more of our senses. So, anything that occupies space, possess mass, and can be felt by anyone or more of our senses is called the matter. So we have to further classify the matter. The matter can be classified on the basis of their physical appearance or the physical classification or its chemical composition called chemical classification. My dear students, first of all, I will talk about the physical classification. I'm writing my main heading to be physical classification. The matter is classified physically into three types. The first one is solid, the second one is gas, and the third one is liquid. So let me talk about solids. What are solids? The matter that has the matter that has definite shape as well as definite volume. That's the solid matter or a solid state. What's the gaseous state? What's the gas? The matter that does not have definite shape nor definite volume. That's the gaseous state. Now I'm talking about the liquid state. The liquid state is exactly intermediate of the solid and the gas state. So what is liquid state? The matter that does not have definite shape but possess definite volume. That's my liquid state. Now let us talk about another type of properties. I'm talking about the solid state first. In solid state, we all know that In matter, there are number of atoms. There are very high number of atoms, in short. Uh, when there are very strong intermolecular force of attractions between that atoms, due to which the atoms are very tightly packed. So here the intermolecular forces, the interatomic or intermolecular forces are strongest, due to which the atoms or the molecules from which that matter is made up of, they are very tightly packed. They does not have any intermolecular spaces in between them. They have a very high intermolecular forces of attractions. This is the reason why that matter is existing in the solid state. The another point, due to this strong intermolecular forces of attractions, they have the highest thermal stability. Highest thermal stability. How can we define the thermal stability? The thermal stability can be defined as temperature required. Temperature required to pull apart atoms from each other in solid state. In solid state, they have the highest thermal stability, so this temperature required will be the highest. That's the meaning of high thermal stability. Now let us talk about the gaseous state. As we all know, in the gases, the atoms are very far apart from each other. The gases, the atoms are very far apart from each other, due to which the interatomic or intermolecular forces are weakest or negligible. So a very less temperature is required to break that weakest intermolecular forces, due to which these gases have least thermal stability. Now let's talk about the liquid state. In liquid state, all the properties are of the intermediate range between the solid and gas. So the interatomic or intermolecular forces are in between. Means in between matlab, I mean the the magnitude of intermolecular forces. The magnitude of interatomic or intermolecular forces are in between that of solid and gas state, and also their thermal stability and also their thermal stability is also intermediate. Intermediate that of solid and gas state. So, my dear students, that's all for the physical classification. When we will do the topics like the solid state, the gaseous state, like liquid or a solution state, we are going to discuss the properties of all these three states in a very advanced or a detailed level. So let's talk about the chemical classification. So I'm starting my next topic, that's chemical classification. Chemical classification. Our chemical classification is also, it is taken in the two parts: the pure substance and mixtures. So let us talk about what's a pure substance. Let me introduce some more lines in the word chemical classification. The classification, the classification which is based on chemical composition of matter. The chemical composition stands for which constituent is present in how much percentage. That percentage can be according to its mass or can be according to its volume. So when we are dealing with the composition of the matter, that stands for chemical classification. Under chemical classification, we are having two types of things: the pure substance and a mixture. What is a pure substance? A single substance. A single substance which cannot be, which cannot be separated into other kind of matter, which cannot be separated into, hold on, a single substance which cannot be, sorry, converted into, which cannot be converted into other kind of matter, nor it can be built and also cannot be broken into simpler substances by ordinary physical methods. Here I am talking about the physical methods of conversions are not applicable over here. That's called pure substance. So what's the pure substance? A single substance which cannot be converted into other kind of matter, nor it can be built or nor it can also be broken into simpler substances by ordinary physical methods, but they can be converted into other substances by chemical methods. I'm just talking about the I'm just talking about which methods? The physical methods. That stands for pure substance. We are having pure substance of two types. The pure substance further is generally of two types. The first one is elements, the another one are compounds. What are the elements? The elements are the simplest form of pure substances which can neither be broken into nor built from simpler substances by ordinary physical methods. The simplest form of the simplest form of pure substance. The simplest form of pure substance which can neither be which can neither be broken into nor built from simpler substances, nor built from simpler substances by ordinary physical methods. Now, let's talk about the types of elements. We are having further three types of elements. The first one is metals. What are metals? These are usually solids. I'm now discussing about some properties of metals. So what are metals? These are usually solids and are normally hard and are normally hard. They have luster. They have luster, comma, high melting points, comma, high boiling points, and they are they are also good conductors. They are also good conductors of heat and electricity. So I have just discussed the most usual and the simple properties of metals. Now, what's the another type of simpler substances, let's elements. What are the other types of elements? The other type of elements are obviously the non-metals. The properties of non-metals are totally opposite to that of metals. Elements with properties opposite to that of metals, that are called non-metals. Let me give you some example of metals and non-metals. The examples like iron, copper, sodium, potassium. I have just write down the symbols. I just wrote down the symbols. Uh, the name and the symbols you all students must have studied in your junior classes. Uh, I'm taking the examples of non-metals. For example, the symbol of hydrogen is H, that of oxygen is O, carbon, nitrogen. The elements and their symbols you all must have studied in your junior classes. Now let us talk about metalloids. Now I am talking about metalloids, or simply they have another name called semi-metals. These are the elements. So sorry. These are the elements. These are the elements that have properties intermediate that have properties intermediate to that of metals and non-metals. Their example is like silicon, germanium, arsenic, antimony, and so on. So I'm done with the elements. Now let us talk about compounds. What do we understand by compounds? Compounds are also a pure substance. A pure substance containing two or more elements combined together in a fixed proportion by mass. So what are compounds? Again, these are the pure substance. Again, these are also pure substance containing two or more elements containing two or more elements combined together combined together in a fixed proportion by mass, and and they can be decomposed into these elements or into their constituent elements into their constituent elements by chemical methods only, by chemical methods. For example, I'm talking about water. What's the symbol of water? That's H2O. What's the weight of hydrogen? That's 1 AMU. How many hydrogens are there? 2. That means I have to multiply this thing with 2. That means what's the total mass of hydrogen in H2O? That's 2 AMU. What's the atomic mass of oxygen? That's 16. So let me find out the ratio of the mass. It's 2:16. In short, or the simplest comes out to be 1:8. This ratio, this ratio is fixed for the water by mass. Whatever can be the source of water. Can it be a tap water? Can it be a pond water? Or it can be a sea water? The ratio of masses in water always remains same. That is 1:8. That's called fixed proportion by mass. Hope my dear students you got this point. Now let me move forward. There are two types of compounds. The first type of compound is organic compound, which I have discussed with you in the very first video called the concepts of chemistry. That's an introduction of chemistry where I have given you the information of organic chemistry, inorganic chemistry, and the physical chemistry. So now I'm discussing about organic compounds. What are the organic compounds? Obviously, you must remember the compounds that have been obtained from living sources, and they are hydrocarbons. That is, the compounds formed by the combination of two elements, that is carbon and hydrogen. That's why we call it a hydrocarbons. Let me give you an example. The example of hydrocarbons, like the simplest is sugar, which we get from the plants. The plants are living sources, C6H12O6, or the sugar C12H22O11. That's called glucose, and that's my sugar. Now let me talk about the another type of compounds, that are inorganic compounds. So what are inorganic compounds? The compounds that have been obtained from non-living sources. That have been obtained from non-living sources. Let me take an example. I'm giving you the example, that is the table salt, NaCl. The source of NaCl is seawater. The NaCl is called salt or a sodium chloride. So that's all for compounds. So my remaining portion is mixture. The remaining portion is mixture that have been left behind. I'm not having space over here, so I'm taking this topic downstairs. Now I'm giving you information about mixtures from here onwards. I'm talking about mixtures now. So what are mixtures? What exactly are mixture? The combination. The combination of two or more elements. The combination of two or more elements, or two or more compounds also, which are not chemically combined, which are not chemically combined. Who are not chemically combined? The two or more elements which are present in mixture, or two or more compounds that are present in mixture. They does not have any chemical combination in between them. When I was talking about compounds, there was also the chemical combination. They are fixed proportion by mass, combined together. They are combined together. They are combined together by chemical bonds. They are combined together by chemical bonds. But in case of mixture, we are not having any chemical combination. Like oxygen, it has a chemical one covalent bond with one hydrogen and another covalent bond with another hydrogen. So these are actually chemical bonds between two elements, oxygen and the hydrogen. But in case of mixture, we are not having any chemical combination. That's the main point. And and they may also be present in any proportion, in any proportion by mass. In case of mixture, we are not having any fixed value, but in case of compounds, we were having the fixed value in water, that is 1 is to 8. So that's my mixture. Now we are having two types of mixture: the homogeneous mixture, the homogeneous mixtures. What are the homogeneous mixtures? A mixture is said to be homogeneous a mixture is said to be homogeneous if it has uniform composition. If it has uniform composition, if it has uniform composition throughout, and and there is not any visible boundary of separation. So, what's a homogeneous mixture? A mixture is said to be homogeneous if it has a uniform composition throughout and there is not any visible boundary of separation between constituents. Let me give you example. It's a sugar solution. Guys, when you dissolve sugar in water, the sugar gets dissolved. After that, you get a sweet water, and the sugar is uniformly mixed throughout the water. That's called homogeneous mixture. And also in sugar solution, you are not able to distinguish between a sugar crystal and water. It has completely dissolved without any visible boundary of separation. That's why we called sugar solution to be the homogeneous mixture. So let us talk about our next mixture. That's called heterogeneous mixture. Heterogeneous mixture. What is the heterogeneous mixture? Again, a mixture is said to be heterogeneous if if it does not have uniform composition uniform composition throughout, and there is also and there is also visible boundary of separation. Visible boundary of separation. Let me give you an example. If you have some sand in water, you can easily clarify that this is a muddy water or this amount of water is having a sand in it. But the most of the sand is present at the bottom of the water. You can easily feel that there is a more concentration of sand at the bottom of water rather than at the top of the water. The another example can be the oil in water. Let us take a glass, put some water and then put some oil. Then vigorously shake it. When you will put down that glass of water, the oil will come at the top and water at the bottom. Let me give you a diagram. That's a glass of water. You can easily feel that, you can easily, see that the water is present over here and oil is over here. And you can easily see with your eyes the visible boundary of separation, between water and the oil. Visible boundary of separation. In case of oil and water. Then another example is sand in water. These are the simplest examples. In case of chemistry, in case of any chemical, I am giving you the example of carbon tetrachloride and water. So these are some examples of heterogeneous mixture. So that's all for the today's lecture. So let me show you one flowchart. Of today's lecture. So what we have discussed today we have discussed, first of all, matter. What is matter? After that, we have discussed its two types of classification, the the physical classification and chemical classification. In physical classification, I have given you the three terms, the solid, the liquids, and the gas. In chemical classification, I have given you the two terms, the pure substance, and another is mixtures. In pure substance, I have given you the further 2 points, uh, elements, the another one was compounds. In elements, I have given you the three terms. I have given you the three terms, that's metals, non-metals, and metalloids. For compounds, I have given you the two terms or the two types, the organic compounds and inorganic compounds. And in case of mixtures, I have given you again the two terms, the homogeneous mixtures and heterogeneous mixtures. So that was my topic for today. I hope you have all enjoyed the today's lecture. So keep subscribe. So please like, share, and subscribe my channel. Please, please don't forget to push the subscribe button of my channel. Stay blessed.